Hi there, I am Alex. Welcome to the second video of a series about vector math for coding. In this video we will cover the very basic vector operators, so let's get started. We begin with the addition operator. By adding two vectors, we get a new vector which is the result of the operation. Visually, you append both vectors by attaching the tail of one vector to the head of the other vector. In order to form the new vector, you just follow the path from the tail to the head of the combined vectors. In the image, C will be the new vector and it is calculated by adding A and B component-wise. Subtraction is similar, but a little different. Visually, you start from the head of the vector with the negative sign and follow through all the way to the head of the other vector. In our example, to form the new vector C, you start at the head of vector B, follow through to the head of vector A. The new vector then spans from head to head. Algebraically, the operation is performing a component-wise subtraction on its components as shown in the equation box. The subtraction could also be represented as an addition by just separating the negative signed vector and putting it in brackets. So this way the vector naturally turns and you could again attach it to the other vector, like we did visually for the addition operation. A vector can be scaled by multiplying it with a scalar value. That is a one-dimensional real number. The result is that the vector will shrink, stretch, or go in the opposite direction. You just saw an example of going in the opposite direction when describing the alternative way of subtraction. The vector b was scaled negatively. In the image, you see some example of scaling in positive and negative directions in order to gain a new vector c. We write the operation as a scaling factor represented by lambda multiplying or scaling the vector a. Let's go through some numerical examples by starting with the addition operation, where you see some vectors added together. And some subtraction. Note that the resulting vector is directly attached to the origin. Covering the multiplication example, I would like to come back to the polar coordinate and the length or magnitude r of the vector. The polar coordinate was introduced in the last video, but now we can scale it properly. There is still one property missing on the polar coordinate we will discover in the next video. Let's scale some polars. With the learned math so far, we can handle a very popular and important interpolation technique, linear interpolation between 2 points. In order to interpolate between the vectors a and b, you simply scale both vectors by a real number lambda, which is in the range 0 to 1, and add both together. Learned about the basic vector operators we have available, and that we can already do powerful operations like the linear interpolation with it. With every video we dive a little bit deeper into vector math, so stay tuned. Share, like and subscribe. Bye now.